Let's look at the next question, which is transient analysis of RC circuit. So here we are having only capacitor with resistance. There is no L component here. RC circuit. Now, as we have done previously, we will solve the problem in two parts. So part 1 is we want to find out which are the initial condition values. For that we have to draw the circuit initially how it is. Now read the question. In the network, the switch is moved from A to B at t is equal to 0. So from A to B it is going at t is equal to 0. So again, as I said previously, the time is divided based on two periods. One is before t is equal to 0 and one is after t is equal to 0. So before t is equal to 0, the circuit we have to draw. So as we can see here, we are having the voltage source, which is 10 volt, and the resistance, there is no change, it is 1 ohms. The switch is connected to position A, and then the capacitor. Now I will not draw the capacitor because the capacitor has been charging for a long time. So we know that after charging for some time or after a long time, the capacitor comes out to be open circuit, and there is a voltage that is developed across it, which is our initial condition voltage V0, and we need to find out that one. So now in this circuit, I cannot draw a current. If I draw that current will be equal to 0. Why? Because this circuit is open circuit. So since there is no current, there is going to be no voltage drop across this resistor, 0. But this voltage is there, which is having a positive and a negative polarity. So I will be able to write KVL. So KVL at mesh will give, so front of the component, so plus 10 volt, minus 0 because there is no current, so the voltage across 1 ohm resistance is 0 volt, minus 0, I will not write minus 0, then minus of V0, V0 minus is equal to 0, therefore V of 0 minus is equal to 10. So that we have very clearly found out. Now we go to the part 2. So part 2, we have to find out these values, I of t and Vc of t. So now if I am going to draw, now see here the switch was in A for a long time, so this capacitor has been kept on charging, but this capacitor has not been charging. So this capacitor we will replace with a capacitance and a voltage source, but the second capacitor which has not been charging, we will not replace with a capacitor and a voltage source, but we will only keep the capacitance there. And remember, we have to write it in the Laplace part. So we will write the Laplace circuit. The Laplace circuit will be, as you can see, the switch is connected only to B, so 10 volt and 1 ohm resistance is not there part of that circuit when it is connected to B. So whatever is connected, I will draw it together. So now the capacitance is there, but it is having a voltage. Now based on how the current was flowing, as you can see, the current was basically flowing in this direction, so I will write this as plus and this as minus polarity. So the value I will write shortly, and this was connected to B, the switch was connected to position B, 1 ohm resistance is there, no problem, and 3 farad capacitor will not have any voltage source because it has not been charging. Now what are the values? 3F we can write it as 1 by 3S. 6F capacitor we can write as 1 by 6S. And the voltage source, if you remember, the voltage source, we had said that it will be V of 0 minus by S, which is 10 by S. Why 10? Because we have got the value of V naught is 10 here. So this is the circuit, and based on this circuit we need to find out two voltages. According to them, I have not mentioned what is I of t. Again, I of t and Vc of t I should have drawn in the problem. So I of t is this current, sorry, and Vc of t is this current. It is actually there in the question, I forgot to draw it. So now inside this, the current will be capital I of S, and the voltage here will be Laplace form capital Vc of S. So let's write the KVL. So the KVL will be, KVL at mesh will be, so starting from here the current is going like this, so plus minus plus minus plus minus. So I will start from the front of the component, so I will write the equation 10 by S plus 10 by S minus I of S by 6S minus I of S minus I of S by 3S is equal to 0. So now I will get 10 by S, all the other values go to the other side, so 1 by 6S plus 1 plus 1 by 3S into I of S. This can be actually changed into, if I'm going to take 6 of S, then 1 plus 6 of S plus 2 divided by 6 of S into I of S, which we all know is 3 plus 6S divided by 6S, from where I can actually take out 3 common. So if I take 3 common out, I will get 1 plus 2S, or let me take 6 common outside because S I want to keep without any values. So S plus 1 by 2 divided by S, okay, and into I of S. I forgot I of S here, so I of S is already there, therefore I of S will be equal to 10 by S into S divided by S plus 1 by 2, which comes out to be 10 divided by S plus 1 by 2. Let me check it. It is correct. So now by using Laplace inverse, I of t will be equal to Laplace inverse of 10 by S plus 1 by 2, which is 10 times e raised to power minus 1 by 2t. So that is the value of I of t. So 1 is over. Next is Vc of t. Vc of t is basically, from here you can see Vc of S is equal to 1 by 3S into capital I of S, which gives us 10 by 3S into S plus 1 by 2. Now to solve this one, we will have to use partial fraction method because there is no other way. So we will write A by S plus B by S plus 1 by 2. We all know we can find out A by basically using the partial fraction method. A can be found out by multiplying this equation with S, Vc of S, and equating S is equal to 0. So if I multiply with this equation S, then I will get 10 divided by 3 S plus 1 by 2, and I'm finding out at S is equal to 0. This value comes out to be 20. S is equal to 0, not 20, 20 by 3. It comes out to be 20 by 3. Okay, similarly B we will get by multiplying S plus 1 by 2 with Vc of S and equating S is equal to minus 1 by 2. So I will get 10 by 3. S is becoming 1 by 2. So again this one minus 1 by 2. So I will write it as minus 1 by 2. So this comes out to be minus 20 by 3. Now based on that I will get Vc of S as 20 by 3 times 1 by S plus, not plus, minus 20 by 3 into 1 by S plus 2, from which we can get Vc of t by taking the Laplace inverse. We know it is going to be 20 by 3 u of t. I'm not going to write u of t now. Minus 20 by 3 e raised to power minus, it is one, not 2, it is 1 by 2. So e raised to power minus 1 by 2t u of t. So u of t I will write out commonly. So that is the solution of this transient analysis.